So welcome to the RSA Conference Lightning Talk. This one is titled Experts Take on Hacker Burner Phones, Automation, and Hardware. In this session, we'll hear from three experts. Each has about 7 minutes to share their big idea. Following their presentation, we'll have a 5-minute Q&A. While they are speaking, please feel free to add questions to the chat here in Zoom. And then as the time comes for Q&A, we're going to get that started. So let's get started. And I'm going to introduce our first speaker here, which is Mark Lovelace, a security researcher at GitLab and a lifelong hacker with strong feelings on security and privacy. So Mark, take it away.
Hi, my name's Mark, and like you said, I'm a security researcher at GitLab, and I like to play with technology, whether I'm at work or not. I love gadgets and devices, and today I'm going to be talking about such a device, the Hacker Burner Phone. Now, a traditional burner phone is intended to be tossed if the number is burned. Think of those old cheap flip phones, but a modern phone, it has 5 radios. 4 of them are capable of transmitting, and for the most part, as long as the phone has power, it can disclose data and location to others via one of these radios. This information can be gathered by data brokers and sold to any number of parties, including advertising agencies and even government agencies, including law enforcement. With apps that constantly gather data, radios constantly broadcasting, it is no longer your phone number that is burned. With the modern phone, you are the one that's burned. So I'm going to cover, or I did cover the technical details behind the data gathering in a talk at B-Sides DFW in November of 2020 in a call, in a presentation called Your Phone Hates You. So if you want to get more of the technical details on what I'm going to cover through here real quickly, just go to my website at marklovelace.net. Click on the YouTube icon and you'll find the talk. But for today, I want you to bear these things in mind. First, the modern phone is horrid for privacy and personal security. Any phone will begin to build a digital footprint of its user, but combining separation of data with some OPSEC, one can create create a completely separate digital identity. And that's kind of the goal. Why a hacker burner phone? Here's some scenarios for that. Human rights worker. You need to be in locations with an evil government that's monitoring you. Use the burner during sensitive operations. On the show Billions, there is the Bobby Axelrod scenario. His tight group of co-conspirators each have a burner only used for communication between each other or, shady web searches or whatnot. The OPSEC isn't rigid by any means, but they regularly swap out all of their burner phones all at once. If you attend protests, using a burner at the protest keeps you in the loop with the world, but any government surveillance that's happening with, say, with IMSI catchers or stingers will only get your burner. The security conference attendee, which should apply to, well, everyone here, should be obvious, but if you're attending a conference such as perhaps one in Vegas this summer, then you want to protect yourself from potential government monitoring, out-of-country spies, fellow attendees, etc. All can be covered via the burner while you are still able to communicate with your hacker friends. Now, to make your hacker burner phone, you have to figure out what phone to get. Think about memory, customization, keep a small footprint in mind, and whatever your budget is. My main phone is an iPhone, but based on my needs and my budget, I chose a Motorola Moto G7. Now, how do you get your burner and not have it traced back to you? That's interesting. The steps I've come up with here are: first, set up a Proton Mail account via personal VPN. Do this via a private window in your browser like Incognito in Chrome, for example. Don't send a test message to your regular email account to test it. That creates a link between you and the new Proton Mail account. Create an Amazon account using your Proton email address, then physically go to a store that sells Visa gift cards. and pay cash for those cards. You'll have to buy them in amounts of less than $300, as $300 triggers a security check where they ask for a driver's license, even if you're paying cash. This rule kind of applies in the US. Load the Amazon account up with the Visa gift cards. Order the phone for delivery via Amazon Locker. Pick a locker site you've never been to. The notification with your 6-digit code to get into your locker will come in email. Okay, now here's how you physically pick up the burner from the Amazon Locker. Bring a Faraday bag, and I cover Faraday bags in that B-Sides DFW talk I mentioned earlier. I recommend bags from either Silent Pocket or Mission Darkness. Don't go cheap. The pandemic is awesome, as you have an excuse to wear a mask, gloves, hat, sunglasses, so no facial recognition. Leave your regular phone at home. Don't park in the parking lot because they'll have cameras there. Think about your vehicle license plate. Park nearby and walk. Unbox the burner in the parking lot. Remove the serial number that's printed on the box for later secure disposal. Toss the box and all of that unwanted paperwork in the dumpster. Place your new burner phone in the Faraday bag, as the battery might have some juice, and keep it there when not in use. Now, to configure things, I'd recommend you go someplace with free Wi-Fi accessible from a parking lot where you can, someplace where you never take your regular phone. Disable everything except the Wi-Fi. Turn on every privacy setting possible. Lock things down really tight. Load up a personal VPN like Proton VPN, for example. Patch and delete all unused apps. Load on a secure browser, something, maybe like a Firefox Focus or Brave. Set your browser's default search engine as DuckDuckGo. And if your burner is an iPhone, you might look into Disconnect. I think that's a disconnect.me or disconnect.io. I can't remember which off the top of my head. Anyway, now that you have your burner, here are some fun tips to keep in mind. Never have your burner outside of its Faraday bag near your home or office, and never out of the bag near your regular phone. If the battery is removable, remove it as much as possible. Only use the burner when it's required, so don't show it off or brag to friends. If you need to switch between burner and regular phone, each should have its own Faraday bag, and don't do it at the same place. Don't walk around with your burner out and your Fitbit that speaks cellular. That kind of defeats the entire purpose of this. Never use your burner to access accounts associated with you, especially social media. And that's pretty much it as far as the Hacker burner phone goes. I will be doing a blog post on this coming up fairly quick, and you will be able to, you can certainly ask me questions via here, or if you don't feel like putting them up in a public forum, you can contact me via Twitter or via my website at marklovelace.net. And there you have it.
Thank you so much. That was really cool. And then honestly, great URL for your website. So pretty easy to find you. I know we have a couple of quick questions that people were asking before this talk started. So one of them was, all right, if I remove my SIM, is that going to defeat, all cellular communications with this burner phone?
No, it's not. Simply because there's two parts to that. There's the IMSI, which is stored on the SIM, and then there's the IMEI, which stands for International Mobile Equipment Identification. I believe it's what it stands for. That one is a unique number tied to your hardware. With that, that's why you're able to not have a SIM in there and still be able to make 911 calls or receive Amber Alerts or weather alerts and stuff like that on the phone. So it still allows for communication, and obviously it's hitting a cell tower. So technically it's still traceable.
Yeah, because you see in the movies, they take the SIM card out and they bite it or something. And it's like, okay.
Yeah, well, that took care of exactly half the problem.
Yeah. So let's see. We got a couple of, I like this one question here. Any tips on hiding facial identity when picking up the phones after pandemic masks sort of become unusual?
Well, I'm planning on wearing a facial mask, and then if anyone asks anything, I'm just going to say, "Oh, I'm allergic to the vaccine. I can't take it," and then
Right.
just continue to wear the mask. I planned on doing that as soon as we started wearing masks. So I
Or
thought at some point this will go away, but this is
picking
just
yourself
too
at like
awesome.
7-Eleven, and it's like, I'm allergic to the hot dogs that are sitting there.
Yeah,
The
yeah,
odor of the 7-Eleven pizzas.
yeah, exactly. There you go. That's it.
Let's see here. Yeah, I think one other question we had was essentially, are there any sort of recommended apps for the burner that you covered one, but what other
Uh,
apps would you put on?
I would recommend Signal. It would be one for encrypted communication. Uh, there are apps that allow for, let's say you can store like the entirety of Wikipedia offline. You can store it on your phone, things like that. Maybe there's some mapping software that does exist where you can store maps. So that way you can get around using the phone, but you don't have to necessarily be tied to having GPS active and that kind of stuff.
I think we might have time for one more question. Obviously, RSA can call me out if we don't have any more time, but essentially, I do like this other question about, essentially, where could one even consult legality on this? Is there legal issues to be concerned about when trying to set up a burner phone?
I don't know. I don't know. That'll probably play itself out in court. There's nothing that I'm mentioning in this at all that says that necessarily says that I'm going to go and commit illegal acts with that. Now, that being said, I mean, it does look awfully suspicious if you're, picked up for potentially committing crime and you've got this elaborate burner phone set up. But the main thing I'm thinking about it is for privacy. And so for that, I don't think it's much of a problem. And I'd say contribute to the EFF. They are your friends.
Right on. Oh, there's a question here sort of about even using prepaid cards over time, it does get trackable. That question sort of going into, I guess, a subscription or making sure that your phone plan is paid for, and sort of limiting.
For me, I wasn't even going to have a phone plan. I was just basically going to use it for just for the Wi-Fi access. So for me, it wasn't too much of a big deal. And all things considered, you could just conceivably just keep moving on and just continually switching out the identity and getting a new phone.
Awesome. Well, hey, Mark, thank you so much. Again, everyone,
please
contact Mark. We're moving on to the next speaker. This is the Lightning Talks, and we got to go lightning fast. So next up, we have John Gleason, who's a senior DevOps engineer at ISE, and he leverages his unbridled enthusiasm for system automation to build and operate cloud hosting platforms. So John, please take it away.
Thanks, Sam, and thanks, Mark, for your talk. That was super exciting. I am going to talk today a little bit about high-level, I have a high-level diatribe on automation. It's not going to get into any specifics, but I'm excited to just rant for a few minutes and hopefully answer some questions. During my talk, I'm not going to advocate for any specific tool, although there will be references to tools and things that I use personally. The major takeaway from my talk should be a general approach, an architectural process or mindset. So without regards to any specific tools or implementation. Give me just a second. I have to move my screen. Oh no, I'm burning my 7 minutes. Okay, fixed. All right, so to kick it off, I have a quick story of an early career epiphany that I had, which sort of shaped my approach for several years. It might not be terribly groundbreaking. And there's a small chance for some pitchforks from some members of the audience, but I have been advocating this mindset within my teams for a while now, and I feel like it's worthy of a little recognition. So here we go. A large portion of my background is in Windows Server administration, and I wrote and continue to write a lot of PowerShell to facilitate operational activities. I could configure entire server farms from image boot to running application with very little interaction. I automate business continuity and disaster recovery activities and application failover and high availability mechanisms for both initial configuration as well as daily operations. Another specific example is I could perform no downtime patching of Windows applications in entire server farms and continue to do stuff like that every day. The things that I mentioned just now, I did almost entirely before I ever touched a CI/CD pipeline, before I ever knew how to use Git or how code commit worked. And most of my scripts and systems were built and deployed by hand for their initial, their initial setup, and of course maintained over time. I kept them on my local system, and I, had to copy them up via RDP or any other mechanism that I had access to. Then one day I was doing some research and came across Jenkins tutorial video and watched kind of how they set it up to perform code build and deployment in response to a code commit. Now, this type of thing is not new, but for me at the time, it sort of clicked in my mind. What sort of clicked was all the code that I write controls infrastructure. So that means that my infrastructure can be automated from this platform. And yeah, of course, infrastructure as code and things like GitOps are terms now that get thrown around a lot. But for me, this was pretty groundbreaking before I really realized what I was, stumbling upon. While everyone was calling Jenkins and other systems like GitLab or GitHub CI/CD platforms, or build tools or software development lifecycle tools, my mind was immediately drawn to the fact that it was really a general automation tool. It just happens to be used for software development lifecycle tasks. It was all downhill for me from there, because I personally, and while I have personally grown organically towards GitLab, the tool itself doesn't really matter. It's about the idea that if you have a problem that you can define as a script or a collection of scripts or tools, you can use those as building blocks to automate problems or issues or tasks using the same techniques that we use in the software development lifecycle. So the same epiphany, of course, has been had. It's not unique to me. GitOps and infrastructure as code are not new, but my takeaway for you today is to think a little bit bigger. Your company's CI/CD platform can be used to automate anything that you can define in code. Any collection of repeatable actions or job tasks that you have in code can be built in a way to leverage that automation capability of your CI/CD pipeline tools. So the next I want to talk over some, oh boy, lost my spot. I'm going to talk over some major bullet points to follow when taking this approach that I'm outlining. I'm not going to read my slides. You can read them while they're there, but I'll touch base on most of them. Just consider my slide and those bullet points supporting to these points. So number one, the key takeaway is, from a mindset perspective, automate everything. And I don't say this lightly. I firmly believe that if the action is worth doing, it's worth having a repeatable process for. Now, it's up to you as a manager or a developer or department to determine the smallest unit of tasks that are actually worth being repeated. But as a rule of thumb, if you can, automate it. Source control everything, even small scripts. If you are going to script or write a repeatable tool or process, the code can't be hoarded on local systems like I did when I was starting out. Commit them, even the small things, even the small single-use scripts to source control. And I recommend this for a couple of reasons. One, obvious repeatability. You never know when you might need something again. And two, code review for automation tools. If you're doing it right, your automation pipelines will likely end up touching production systems. So testing and review is paramount. There's sort of a third hidden benefit as well. With enough small component scripts, you'll over time build out this library of capabilities. You'll be able to choose from when creating new systems, sort of like building blocks. A library of everything that you create with repeatability and modularity in mind. you'll be able to use them for new projects while maintaining a familiarity and a common ground, ever-growing tool set. This mindset for committing even small scripts to source control affords you a way to think about problems as discrete actions. And from those discrete actions, you'll be able to architect and draw out workflows for the task at hand. Using the common language of your scripts, these workflows, you'll build a workflow, and these workflows are how you end up defining your CI/CD tools pipeline to construct your automation system. When writing these scripts, I found that it's important to build assumptions into the defaults. Allow for configuration or parameterized overrides, but the scripts should be opinionated. This way, the default behavior is the most common use case. What you want, you can derive input and output tolerances based on future needs. So essentially what that means is have some inputs that are defaulted and then allow the script to grow or contract or shrink depending on what you might need. Don't go too overboard in handling every edge case. Just make sure that you have a solid default state. Solve for the problem now with a mind for iteration in the future. You'll likely never be complete because you will continuously want to improve the process and your pipelines will change over time. With your defined issues and tasks being solved with source controlled automation pipelines, you immediately and without additional overhead get the visibility and traceability that source code repositories afford software teams. Not only do you know when a commit was made that triggered some environment change or triggered some process, you also know who performed that change. And if something isn't right about the output of the system, you can simply fix it in code, commit again, and the pipeline will run, and the automation will take care of the state of the system. This is a desired state or a declarative state type of way of thinking about things. You can configure your pipelines to support different environment layers for testing of automation pipelines. Think prod and non-prod environments. You use that with like a branch or a tag style system in source control. And it's a really neat way of going about building automation systems. I personally advocate for it based on nearly 5 years of cloud production usage. It can be used for internal systems as well. And I'm running out of time, but I do want to touch briefly on a couple of challenges that come up. The security challenge is one. And the reason it is because depending on the configuration of the GitLab or Jenkins or whatever automation pipeline you're using, you have to really have some strong foundation around role-based access control. And iteration time can be a little bit of a challenge. Basically just how long it takes to make a change, commit it, and then have the pipeline run. So I will go ahead and call it there. That's my my slide, my topic, and my presentation. And I'll turn it over for questions.
Hey, thank you so much, John. Let's see here. One of the questions we had was kind of how do you know when an automation project is done?
Yeah, that's a bit of a trick question, and really, you automate a task so that you can say that you don't have to do it manually in the future. That makes the task complete. The automation project itself likely will always need a little bit of tweaking, a little bit of iteration. So really, it comes down to maintaining a backlog, just like any other software development lifecycle. You'll probably, or software development project, you'll probably never be done, but you will get to a point that is sufficient for the use case. Particularly when you're talking about building out a tool set or a collection, a library, you will always want to iterate on that. So you're never really done, but you can get to a point where the pipeline that you've built is doing what you want it to do. So.
All right, cool. And I think one last question before we move on, which is from Paul Vincent. He's asking, what if automation costs more than just doing it manually, at least for the foreseeable future, right?
Yeah, that's a balance. You really do have to think about that. And it's probably going to end up on some sort of graph somewhere. And it might even behoove you while you're thinking about a project to try and graph it out. Because if it takes you 10 hours to do a project that, automates a 10-minute process, you don't really reap benefits from the automation for several years, depending on how frequently the problem is. So, the idea, the mindset is to automate everything. But of course, individual tolerances and teams and consideration is required for every project.
Right on. I think we actually have at least like 30 seconds left, and I know that there was a topic here that we were talking about earlier, which was how do you get support from security teams or compliance teams with automation? So that might be the last question I'll hold on.
Security teams and compliance teams should love this idea because you gain visibility, you gain repeatability, you gain traceability. Everything that a source code management system affords a software development team, you can leverage as an infrastructure or as an automation pipeline team. And security will reap the benefits from that if they are involved in the decision making. Platforms such as GitLab afford environment variables and secrets that can be masked. And so there's a ton of ways to securely create these pipelines, including with the use of sensitive credentials and secrets. So that's how you do it. Involve your security teams and involve your compliance teams in the design process. Show them how the process improves their goals. Awesome. Because it does.
Thank you so much, John. And you gotta love that GitHub. I mean, not GitHub, GitLab love. So love for GitLab.
Thanks, Sam.
Let's see here. We'll move on to our next and final speaker of the day for this session. And that is going to be Keith Ribello, who has the best job in the world as a program manager at the Defense Advanced Research Projects Agency, might know it as DARPA, where he is creating the future of hardware security. So with that, Keith, take it away.
Thanks, Sam. I packed a lot in here, so let's get into it. So when we think of security, we normally think of software, right? There are vulnerabilities in software that are attacked with software exploits, that are fixed with software patches. But I'm here to tell you that we should really be thinking about hardware. The plot on your screen shows data from Mandiant and FireEye, who looked at 60 vulnerabilities discovered from 2018 to 2020. For each, they analyzed the time difference between when a patch was issued and the first time that vulnerability was exploited in the wild. These results show the failure of software patching to keep us secure. On the right side of the graph are zero-day vulnerabilities, which are discovered and exploited by attackers before a software patch is available. In some cases, attackers were exploiting these vulnerabilities for months or years before defenders discovered them. On the left side of the graph are vulnerabilities for which patches already existed, but where attackers still found success in developing and using exploits for the vulnerabilities after software patches were available. How are they successful? Well, the reality is that even when a software patch is available, patch deployment is often incomplete. Systems can remain unpatched and vulnerable for months or years after a vulnerability is disclosed. This problem is especially pronounced for embedded and IoT systems where it can be very difficult to incorporate and roll out software patches. So we know that software patching doesn't work, but how can we do a better job? At DARPA, we decided to look at the root of the problem, the hardware. When an attacker exploits a vulnerability, they are directing the hardware to perform an action in a way that the software developer didn't intend. That could mean accessing memory beyond the bounds of an array, reusing a pointer to a piece of memory that a heap manager has already freed and reallocated, performing a calculation that overflows the hardware's native register size, or changing the order in which the hardware executes instructions. All of these actions are traditionally allowed by the hardware because the hardware has no knowledge of the programmer's intent. For example, there's no way for the hardware to distinguish a memory access that the programmer intended from a memory access that an attacker is using to exploit a system. But what if we built better hardware? Could we improve security and prevent exploitation of systems? DARPA's System Security Integration through Hardware and Firmware, or SIF program, is looking at doing just that. SIF aims to close entire classes of weaknesses that lead to system exploitation with the goal of making systems that can't be exploited even if the software is flawed. Performers on the program have developed a variety of novel techniques to build better processors, including memory tagging to inform hardware about its intended use and bounds, using limited capabilities to restrict hardware operations, analyzing the context of hardware operations at runtime, and using encryption and compartmentalization to protect valuable assets in hardware. These techniques have been demonstrated on a range of RISC-V processor types from 32-bit microcontrollers all the way up to 64-bit out-of-order high-performance CPUs. The performers have validated the security protections using formal methods and a suite of synthetic security benchmarks. And most importantly, they've demonstrated that they can provide these protections with minimal impact to performance, power, and area. But the history of computer security is littered with examples of systems that were believed to be secure, but that ultimately fell to attackers. To evaluate how effectively the SIF technologies prevented real-world cyber attacks, DARPA held its first bug bounty midway through the SIF program. Produced in conjunction with the Defense Digital Services Hack the Pentagon program and hosted by SYNAC, the Finding Exploits to Thwart Tampering, or FET bug bounty, allowed security researchers and white hat hackers from around the globe access to emulated computer systems based on SIF technologies. These systems included unpatched software stacks with multiple known vulnerabilities, many of which were easily exploitable on systems using conventional processors. The results from FET were striking. After over 10,000 hours of attack by over 500 security researchers, the SIF processors demonstrated that they were able to successfully prevent exploitation of the vulnerabilities in the provided software stacks. This result was reinforced by an independent analysis by the Microsoft Security Response Center, or MSRC, who looked at one of SIF's architectures called Cherry. They concluded that over 2/3 of the security vulnerabilities reported to the MSRC in 2019 would have been deterministically mitigated. That means that they would not have required a security update on systems using SIF. To further explore the bounds of SIF technologies, FET security researchers were granted extraordinary access to probe the hardware defenses. This included root-level system access and the permission to develop any software application they could, which exhibited a weakness that should have been protected by SIF. Using this access, the security researchers were able to provide valuable insights into architectural weaknesses, which are being addressed in the last part of the program. To learn more, tune into SYNAC's Bird of a Feather talk immediately after this session. So where do we go from here? We've demonstrated that hardware designed for security can offer strong protections for systems that have flawed software. These protections can prevent exploitation of flaws that previously could only be addressed with software patches. The SIF program now is focused on transition to make this technology broadly available. This includes extending SIF protections from RISC-V processors to processors based on the ARM and x86 instruction sets. The SIF program is fabricating an ARM processor focused on embedded applications using SIF technologies, and the Morello program, funded by the United Kingdom's Research Institute, is funding ARM to fabricate a prototype high-performance processor based on SIF. We're also looking at how software can more efficiently, more robustly, and more resiliently use hardware protections to provide processors defenses against malicious applications installed by unwitting system users. This will require adaptation of application software to use hardware security resources and the tailoring of hardware to meet application needs. We're calling this process hardware-software co-design for security. In this context, we also want to extend system protections to address the threat of malicious or compromised hardware. Black box hardware IP cores, unverifiable firmware, the threat of compromise by user-attached hardware peripherals require us to have a zero-trust architecture model to maintain system security in the face of hardware peripheral compromise. Security is much more than a software problem. Looking to hardware, we have the technology to build secure systems that release us from our reliance on software patching. To learn more, reach out to me at keith.rebello@darpa.mil. Thank you.
Awesome. Thank you so much, Keith. That was really interesting. So now we're moving on to the last Q&A segment of the day for Keith. So as people are typing in some questions. I know that we have some internal questions that we were thinking up ahead of time. And, you know, obviously the main one is this is a brand new thing, brand new initiative for y'all. So where can we really learn more about this?
Well, so, you know, in addition to reaching out to me and going to the SITH website and the FET website, I really didn't get a chance to talk about it because we had limited time. But one of the cool things that we're doing on SITH is we're building a demonstrator. So we're taking an actual car, a smart car in this case, and we're ripping out the engine control unit and the infotainment system, and we're replacing those with SITH processors to show how we can now make the car resilient and immune to cyber attacks. And so keep on the lookout for that coming later this summer. We'll be giving a talk at Black Hat and at the Electronics Resurgence Initiative in October. So stay tuned.
Right on, right on. I used the word immune there for a second. So is this something where, you know, over time it gains a better understanding of how to defend itself against attacks?
Well, there's certain technologies that we've been developing that can be updated over time. But that is definitely something that we're, you know, interested in developing technologies that are adaptable and learn on the fly. And, you know, that feeds into this whole resiliency theme that we're talking about here at the conference.
All right, cool. You were talking about, you know, being able to like show some demos and some of that stuff later on over the course of this initiative. But when can we start to expect to see it available for use?
Yeah, so we're, you know, currently building hardware. So we have the processor that ARM is building, and that's going to come out calendar year 2020. And then the processors that we're building at DARPA, that'll be available in calendar year 2023. So pretty soon.
Okay, cool. Something, you know, that a group like myself might be interested in, or other people in the audience who are maybe practical security people, you know, vulnerability hunters or people like that, is what sort of classes of weaknesses or issues is the SITH going to protect against?
Right, yeah, so you know, what we did was we took the MITRE CWE database, so the common weakness enumeration database that MITRE has, and we grouped those into categories that just solely focused on hardware vulnerabilities. And so we came up with about seven categories. So things like buffer errors, resource management errors, numeric errors, information leakage, injection, privilege, permissions, and access control errors, and then hardware and system on chip implementation errors. So those are the 7 broad categories that we aim to close down on the program.
Okay, right on. Let's see. Any other questions from the audience? I know that internally we sort of wanted to also cover maybe, you know, earlier in this process that you know, you learned some lessons from a previous session, the FETT program.
Yeah, so, you know, we learned a lot of things about performers hardware implementation, so little nits and bugs, but you know, the main thing that we learned is that you can't look at the hardware in complete isolation. There's other parts of the system that we depend on for security, so firmware and some software that's above that. And so the correctness of pieces of trusted software is also really important to address when you're developing the system.
Okay, awesome. Well, with that, I know that we have just about, I think, 30 seconds before the end of the session. So I'm really awesome that we got to meet all of you, hear from all your different perspectives, and you know, get everyone's questions in here. So with that, thank you to all the speakers and to our audience for joining us. Keep the participation alive. Please feel free to engage everyone, you know, with their contact they provided here. So yeah, thank you so much for everyone being here.